Hey everybody, this is video 811 and we're going to be working on synthetic division. This lesson was taught in class, but just in case you needed a refresher or you wanted to go back because something was unclear, these are the same examples that I did in class, but you can watch me go through them again. So here we've got a trinomial that is of second degree, and we're dividing it by a monomial that is linear. So this is a quadratic being divided by a linear polynomial. So when we use synthetic division, we're going to be using the opposite of the number that we are dividing by. So I'm dividing by x plus 2, so I will use a negative 2. Then we draw our synthetic division bar, and I only use the coefficients, in this case 2, 7, and negative 5. Here I'm going to add down. If you'd like to consider this a 0, you can just add a 0 and then you get a 2. On the outside we always multiply, but the number that we get when we result from multiplication goes inside of the division bar. And then once again, we add. So you're always adding down. So 7 plus negative 4 is 3. And then we return to multiplication. Negative 2 times 3 is negative 6. And once again, we're adding, so we get negative 11. Because our goal here is to divide one polynomial by another polynomial, the result should look like a polynomial with a remainder. Sometimes it has a remainder of 0. In this case, it does not have a remainder of 0. Remember, this right here is the remainder. So the answer for this one, because we have a quadratic divided by a linear, is that this polynomial goes down 1 degree. So it's now 2x plus 3 with a remainder of minus 11 over x plus 2. And this is the final result right here. Let's try another. Okay, once again, we're going to use the opposite, but this time we have a cubic being divided by a linear. So I will have the opposite here. It's also important to notice that we're missing a degree. We're missing the quadratic term. I have the cubic term, which has a coefficient of 4. The missing quadratic term has a coefficient of 0, and then a 1 and a 2. We'll just proceed the same way. When I add down, I get a 4. When we multiply, it's 4. When we add, it's 4. When we multiply, it's 4. When we add, it's 5. Multiply, it's 5. And add, and we get 7. So because we started with a cubic, the result is going to be a quadratic. And this 7 is the remainder. So I can go ahead and drop this down and say, well, if it was a cubic, now it's a quadratic. And then I just continue to reduce the degrees until I get to the remainder, which I write over the linear term of x minus 1. And this is the resulting polynomial after using synthetic division. I got one more example. All right, so here we're going to once again, I've got a quadratic being divided by a linear, so I will use the opposite, and I will also replace the missing piece with a 0. So I have a 1, a 0, and a 9. And I will add down, because there was a 0 here, and then I get a 4, and a 4, and a 16, and a remainder of 25. Because it was a quadratic, the result is linear. X squared plus I just did it wrong, x plus 4, and then my remainder of 25 over x minus 4. This is the resulting result from dividing that quadratic by this linear polynomial. All right, great job.